Today I am joined by Stef Ziel, who is the founder of JetStream. And let me say this about JetStream. If you haven't heard of them or you're not familiar with the company, they have some really interesting numbers that will probably pique your attention. And some of these I know Stef is going to be talking to us about today. But imagine this. 40% TCO reduction is what they're able to give their clients, users of their network, of their platform. They have 100% uptime. They have been GDPR audited, which is very significant, especially if you're streaming and delivering content in Europe. Um, they're 430% faster. Now, this one, even I had to raise my eyebrow a little bit and go, let's see how they do that. So I know Steph's going to get into the details about how the system is built and what that actually means. They support 8K. So that's pretty unique, and they have integrated with 9 CDNs. And so that's a little overview of JetStream. And Steph, welcome to the Voices of Video.
Hey, Mark, thanks for having me on your show. Really cool.
So I have to ask you a question. Did you really invent streaming, as you claim?
Yes,
Tell us the story.
that's the claim. Yeah. So we started producing our first live stream in 1994. That's quite early in the internet days. So most people did not even know about the internet, and we were doing live streaming. And it wasn't full
Yes.
HD or 8K or 4K. It was a small postage size. It was 1 frame per second, but it was live. And we don't know anyone else who was before us. So yeah, we were the first, as we hope to be able to claim.
Give us a short overview of the company. How did you jump from 1994 to 2023, and then we'll get into talking about I know a very interesting use case.
Of course, 1994, it wasn't a company. We started the company, I think, in 2003 after pioneering for many years
Mm,
with live streaming. We broke down the internet here in the Netherlands by having so many viewers, so we overloaded the internet. And so in 1997, we built our first CDN, which was a temporarily CDN to do a large-scale live events. And then we broke them down after the event was over. And then for the next event, we built up a new CDN. That's how we did it back then. So we were first in production. We were really going with cameras and encoders to locations, doing the entire streaming. But at one point I said, that's not really scalable. Let's build a streaming platform. We have so much knowledge and experience now. Let's build a streaming platform as a permanent platform. And that's what we did. And I think the company grew 1,800% in the first 5 years. So it's like, boom, streaming became hot when people got broadband. Basically, that's how it started. And then we started to develop our own software because we were running, Windows Media, Real, Icecast, and QuickTime streaming servers and manually helping customers. But because of the size, we needed to develop something that automated provisioning, customer provisioning, live stream provisioning. So that's what we developed. A piece of software, we called it Video Exchange because we could exchange videos with customers, workflow orchestration stuff and edge service deployment and all that stuff. And it was really cool technology. And we started to license it out to telcos so they could build their own CDNs. But after a few years, we decided to go SaaS all the way, just host our software and scale it up. And where we are today is we run our own cloud. It's called JetStream Cloud, of course. And yes, it's 430% faster. We tested customer streams, full HD streams over multiple clouds and CDNs against our own cloud. And streams, the video chunks of the 1, 2, or 4 seconds, for instance.
Yes.
The download time from our cloud is more than 400% faster compared to regular clouds because we're not a generic cloud. We are an optimized streaming cloud. So we don't use virtualization. The network package is optimized. We have hardware software integration with the caches. So everything is done for tuning to be able to burst out those video chunks as fast as possible. At one point, you can ask, what's the point of delivering video chunks at 50 speed instead of 25 speed or 5 speed? But once you go into the 8K territory, that's going to make sense. You want to be able to burst out those
Yeah.
very large pieces of video to those users. And another
Yeah.
benefit is that when you can burst out those video chunks at the highest bitrate to the users faster, the video players will analyze how fast they get those chunks in. So the chances are higher that you go to the highest bitrate in the ladder compared to other clouds and CDNs.
I want to get into a use case that I know that you're building solutions around and deploying that I think is pretty fascinating. And it's this whole idea of a localized OTT network. You know, when I first heard the phrase from you, and of course we're collaborating on a couple projects, I drew my own idea of what it actually meant. But it turns out there's quite an interesting application. So, you know, first of all, tell us what is a localized OTT network, and why does it exist?
It's funny because when you talk about OTT, you talk about world domination, right? You have Netflix and
Yeah.
HBO and want to conquer the world and reach every piece of the continent. And that's what we try to help our customers as well, because we know we have all these CDNs on board, so we can deliver into every continent. And if one CDN doesn't perform, we can switch over. But there are some gaps there. I mean, this is about global streaming, but there's another market, and that's localized markets. What about
Yeah.
real local remote areas like compounds in the desert? You can
Mm-hmm.
have like 1,000 or 2,000 households in a location, but the backhaul connection can be really poor. But still, those people want to be able to watch a decent OTT stream. Not just that use case; it's also offices, hospitals, hotels, holiday parks,
Mm-hmm.
um, uh, university dorms. People want to watch television on their cell phone or iPad, but if
Mm-hmm.
10 people are doing that, that's fine for the local network. But what if thousands are doing this? And what if the
Mm-hmm.
backhaul isn't really that strong to even get, like 80 quality, high quality full HD streams in? So then you need local
Sure.
encoding, local transcoding, and local serving, and that's what we developed. We call this deep edge OTT. It's an appliance, and we built it together with your technology with NetInt, and it's a one rack unit. So you don't have to buy like 5 huge servers anymore with CPU encoding. It's a hardware accelerated
Yeah.
solution with our software, and it's got 3 components. It's a live encoder, it's a transmuxer to
Mm-hmm.
create HLS and dash streams, and it's a deep edge cache. So it's a local cache, so you can actually use it also to serve out the streams to the local users. You don't need an extra cache or CDN there. And the challenge in those locations is that it's not just a remote location with a poor internet connection. Most of the time, there is not that much local physical capacity and power as well. So we needed a
Mm-hmm.
solution. We actually had a customer coming to us, and they said, "We have these compounds and gated communities in our countries, and we need to have local IT TV there, but hundreds of stations per location. And if you talk about
Mm-hmm.
hundreds of streams you need to convert on a CPU basis, you talk about deep investments in hardware and CPU power,
That's right.
but
That's
also
right.
in energy consumption. And the solution we created can convert 80 live HD channels in just with this one new chassis, which is pretty cool. It's like 20% faster, more efficient compared to CPU encoding, and it can serve up to 10K, 10,000 concurrent viewers with just this machine, which is pretty cool. And I think one of the most important USPs is savings. And we've been talking to these customers, and they said, "Yeah, but if we need to buy this hardware, all these servers of the CPUs, there's no business case. We will
Mm-hmm.
we will spend like
Yeah.
80K per location, and the energy bill will be
Yeah.
even higher after so many years.
Yeah.
So there's
That's
no
right.
even, yeah, I mean, with the current energy prices, that's really a challenge. I think
Mm.
after 3 or 5 years, you're spending more on energy than on physical encoder. That's
Mm-hmm.
a problem.
Mm-hmm.
So the cool thing about this solution is that I'm just reading it, 72% lower capex. So per stream, you spend 72% less on investment for encoding that stream. And that's just the hardware. We did not even take licensing, software encoder licensing into this equation. And it's using 89% less power compared to CPU-based encoding, which is also really impressive.
Wow.
And the physical
Wow.
footprint is
Yeah.
just a one unit rack unit server compared to,
Yeah.
stack of.
Yeah.
This is what the interface looks like. I'm not sure if you can see it, but on the left side, you have a config page where you can create those channels. You can get MPEG transport streams in or SRT or RTMP, or you have a config file at JSON, which you can remotely deploy on the server to update the channel configurations. And on the right side, it's
Mm-hmm.
got a built-in video player for HLS and Dash, so you can preview if the stream is okay. And there's a URL which you can publish in like a middleware
Mm-hmm.
service or on a portal or wherever you'd like. And normally, if you start trading off quality for power consumption or cost,
Mm-hmm.
you will go down in quality. But we checked it against the CPU encoders we already have, and the hardware encoding quality was up to par with the software encoding, which is really cool. And it can go up to 4K encoding. So yeah, you can get ultra
Mm-hmm.
high definition quality out of it. Um, and also addressing it by standard, we will use H.264 because that's widely adopted, but it can also do H.265, which is even more efficient. And the latency is really small. We've seen sub 3 frames latency in the transcoding. While with CPU
Yeah.
encoding, you talk about seconds. That's
Yeah.
amazing.
Of course.
And of course, with software encoding, you can do some tuning like forward checking, but then the latency will just explode. So yeah, I think this is a really cool solution for OTT live solutions. And there are actually three components in there. The first one is everything we do, we build it in Kubernetes and Docker or container environments
Mm-hmm.
because we run our own cloud. And everything we build on our cloud is contained by Docker. So you have isolated self-restarting services. So it's low maintenance, high uptime.
Mm-hmm.
And we have our software encoding services running on top of that. So they're running within this Kubernetes environment. And then we use the NETINT acceleration cards. So the ASICs to do the real high performance encoding. And that's a great combination. This is the schematics. I can put it on full screen for you so you can see it better. And
Great.
so on the bottom, there's just an open x86 chassis with 10 of those x86 cards. And I believe they're just using like 7 watts
Amazing.
per card. So the
That's
energy
right.
is really low. And then on top of that,
Yeah.
we run, of course, the operating system in Kubernetes, and then every transcoding process is an isolated container. So if one crashes, it doesn't bring down all the other channels. And if it crashes, the
Mm-hmm.
Kubernetes system automatically restarts it within the buffer size of the user.
Mm-hmm.
So you don't even see that there was a restart or a crash or whatever. So
Mm-hmm.
it's really rock solid. And then we have
Very stable.
yeah, and there's an edge cache running on top of it, and then of course we have some API and GUI stuff running on top of that. So it's like
Mm-hmm.
a hybrid solution between hardware accelerators and this software stack to do this stuff.
Mm-hmm.
And this is basically the process. I can put in a full screen as well. On the left side, you have the transport streams, MPEG-2, MPEG-4, or SRT or RTMP coming in. We scale it in software, and then we decode it in hardware and encode it in hardware. And then the packetizing is done in software again. The chunks and the manifest files are stored on the local storage with a DVR window if you need this. And then there's an
Mm-hmm.
edge cache. Actually, that's two for redundancy reasons with a lot of streaming optimizations like thundering herd, thundering herd protection, smart caching stuff for live
Mm-hmm.
streaming. So
Yes.
yeah, so it's one solution that can just do this. And what I like about it is that you can cluster it. You can have multiple of those servers in one site. Because if you go from 80 to like 160 channels, you can just add a server
Mm.
and it will just automatically load balance
Yeah.
it. That's the beauty of Kubernetes. It will just say, oh, there's a new server.
Wow.
Let's just share the load of the encoding, but also share the
That's
load of
right.
the viewers over the machines. Um, and if you put
Yeah.
in three, you have a high availability server. So one machine can entirely break down, but everything will just automatically keep working. And that's nice. I mean,
Mm.
you don't want to have an operator in a hotel or in every hotel facility that you have to, to restart the machine, and it just needs to be able
Yeah,
to
that's
run.
right.
So
Yeah.
yeah, it's got scalability and high availability. And then we also thought about orchestration because, if you have one location, that's fine. But what about two or five or 20 or
Mm.
100? We can monitor it from a central facility from our cloud. So you can have all
Mm.
have all these satellite encoding locations. And then centrally, you can deploy the JSON file for the configuration. So if you need to add new channels, you don't have to call the hotel and say, hey guys, just add this channel and
Yeah.
put in this RTMP link, whatever. No, you just update the JSON file, push it, and boom, there's a new channel. That's the
There
idea.
it is.
Yeah.
Wow.
And
Wow.
then we thought, okay, we can go even further because the machine is logging and creating log files, and we can actually
Hmm.
push those log files as a stream of data to our cloud and then
Hmm.
process it to statistics. So you can have, uh,
Of course.
yeah, of course, we have this
Yeah.
elastic system running in this cloud, processing and
Sure.
chunking, the way you said it, going through all the log files and making sense out of the session. So then you can have reports like how many views do I have per location, what's the most popular channel, what's the average viewing time, and from which cities or countries are people watching those streams, and all that data is there as well.
Hmm.
Um, so you can think of kind of business models that, okay, which channels do I want to pay for because they're not watched anymore, but the
Yeah.
most popular channels get more. You can build those kind of
Sure.
cool things. And finally, last but not least, we can actually put it into a mix. So let's say you have like 2 or 3 CDNs serving out capacity. We can add those
Hmm.
machines uh, at those locations to have extra local capacity. So deep edge capacity in certain locations. So
Hmm.
if traffic comes from a certain hotel or from a compound or from whatever location like an office, we can recognize down to the IP address that the traffic is coming from that location, and then prioritize
Hmm.
traffic through the deep edge. So it's not just
Hmm.
the streams from the local machine that it can serve out. It can also become an edge for the cloud and for the CDNs. So we can have a
Hmm.
localized edge server running there, which
Yeah.
can also offload internet streams and on-demand videos. So yeah, that's
Mm.
that's the idea.
Super powerful, and there's a lot to unpack in what you just presented. Thank you. A fabulous overview, by the way. One of the things, just to point out, and I think everybody got this, but we're talking about 24/7 live channels. So
Yeah.
this is like linear streaming. This would be impressive if it were even file-based, VOD. But do you have the notion that you can support both VOD and linear live on the same system? Do you have a different way that you handle that? How do you handle, file-based delivery?
This deep edge OTT solution was built for live. So the
Hmm.
use case is we have so many live channels from satellite or cable. We
Yeah,
need to convert it to OTT streams like HLS and Dash and serve it out.
sure,
That's the
sure, sure.
but of course, for the transcoding part, we also do VOD transcoding in our cloud. I mean, we have
That's
customers.
right, because of the cloud DVR functionality. So,
It's not just a DVR, but it's also live to VOD. I mean, we have customers recording live streams and then offering them as
mm-hmm.
on-demand videos. Or we also have a lot
Mm,
of customers in our cloud who are not doing live streaming at all. They just have an on-demand
yeah,
video library, like an OTT
yeah,
service
yeah,
or or a marketing video library for an enterprise. And they want to upload these
sure,
videos, and they have to be transcoded as
sure.
well. And we use the same
Hmm.
technology stack for this. So we started with software.
Amazing.
We have our own cloud with the CPUs, and we thought, okay, if we build this transcoding software, we can utilize the CPU power in the cloud, but we will
Yeah,
switch to hardware transcoding. We will at least
yeah,
uh, a lot of the transcoding will be done by hardware in the future because it's so more efficient and scalable compared to CPU-based encoding.
I was going to ask you about your journey from CPU and software based, encoding to hardware. Maybe you can give some more insights into what really drove that. In our talking to the market, to the ecosystem, we find the usual. A lot of people just say, well, it's just purely cost. It's just our operational costs. But there's some other factors as well. And I'm just curious, for you, was it just purely an economic decision, or were there some other factors that drove you to even explore hardware and then ultimately
Yeah.
land on ASICs?
As a software house, of course, hardware is like we don't like appliances. We don't
Yeah,
like we only want software.
exactly. Yeah.
Um,
Yeah,
uh,
you're virtualized. Everything's virtualized. So it's like, well, what are we going to do with hardware?
actually,
So,
like 10 years ago, we went to a show in London where a lot of vendors tried to sell their appliances to the telco industry and build CDNs. You
yeah,
know, at Cisco with a stack of appliances. It would cost you like €1 million to build a stack for
yeah,
just a POP. And I went on stage and
yeah,
I said, "Hey guys, I have news for you. The appliance is dead because now we have software controlling everything and software edges. So forget about this." So one half of the audience was turning white because those were the vendors, and the other half of the audience was
yeah,
like, "Okay, let's have a meeting." So, but
yeah.
now,
Let's talk. Yeah,
but things flow
yeah,
back and forth. So now we're like, okay, but
yeah,
there are some limitations in software. If you talk
yeah.
about scalability and cost. So our arguments were not just cost factor, but also about scale, which
Mm,
in the end, of course,
mhm.
again, is cost. Um,
Yeah,
but
that's right.
yeah, but to be able to do more VOD transcoding and more, especially for, I mean, VOD transcoding is not even that hard because it's not linear. It doesn't have to be real time.
Yeah,
I mean, it can be faster than real time, but not necessarily.
sure.
But for live streaming, to have capacity for customers to say, "I need to start a live stream right now," and it has to be transcoded to
Yeah,
4 or 5
yeah,
bit rates,
yeah,
you need to have a lot of headroom in your cloud to be able to do that.
yeah,
And we were like, okay, if we do
yeah.
that in software, we will have to buy a lot of equipment, which will just be eating dust 90% of the time. And it will use a lot of energy. And we want to be as
Mhm.
green as possible, with
Yeah,
not just with green energy, but also with a small footprint. And so we were like, if
yeah,
we use these cards, we will have much better
mhm,
scale. And
yeah,
we don't have to invest and overinvest into infrastructure for that, those
mhm,
few days a week that customers are peaking with a lot of concurrent live encoding streams. Today, all the internet streaming basically is H.264. As soon as you need to go to H.265, which is not that popular, but if you want to go to AV1, for instance, which we think will be a dominant encoding format in the future, you have to throw a
mhm,
lot of CPU power against it for encoding, which basically
yeah.
breaks the business case for AV1. And with hardware accelerators like the ASICs, that's instantly becoming a feasible business case. So
Very interesting point that you make is that there is, and we talk to many of our customers and companies who are seriously evaluating hardware, particularly ASICs. And behind closed doors, a lot of them do reflect that, 3 to 5 years ago, if we'd approached them, they would have just flat said, go away, like
yeah,
hardware,
yeah,
like good luck.
yeah,
And so they're, but the point is now they're very very engaged and very leaning forward. And also what's really fascinating is that it's not that it's just kind of a temporary situation of, for example, energy costs, or even, okay, the CEO has mandated, we need to trim 20% from the budget. And so, well, how are we going to do that?
yeah.
Yes, yes, those things sometimes start the conversation, but there's so many more benefits. And like you point out about the advanced codec, the next gen codec support,
Yeah.
the industry has just gotten to a point now where codecs, the next generation, if you look at the complexity of VVC, let's say, just to, but all AV1 as well. So
Yeah.
VVC over HEVC or AV1 over VP8, VP9, the VPX codecs, it is so significant. And when you factor in, even if you're able to get, which on day one you never get the 50% promised savings in bit rate, it's more like 20 or 30%. But in time the codecs get optimized, right? But so even best case scenario, let's say on day one you could get 50% savings. The added compute cost through the complexity of the codec, it negates all those savings, and in some cases and then some.
Yeah.
And so it's this real conundrum that the industry is in, because on one hand, we want to always be moving to more efficient codecs and want to be pushing our bit rates down, resolutions are only going up, customer quality expectations are increasing, and yet
Yeah.
for many services and platforms, they're kind of stuck. But hardware, in particular ASICs, are the breakthrough, for that. And so, yeah, we are seeing a really phenomenal. I know of two, file-based, very high-profile premium streaming services right now. They're on the cusp of deploying hardware, and it's in a use case that, I think a lot of, traditional uh, streaming engineers might say, well, no, you can use CPU for that. And guess what? Their conclusion is, no, we can't.
If you have to encode a film once, and then you can stream it to millions for years, then of course the business case for high cost encoding is better. We have a lot of customers in niches, and they need very high
That's
quality,
right.
but they don't have these large audiences.
Yeah.
So then
Yeah,
there's simply no business case for the encoding if you do it in software. So,
that's
but I
right.
think there will still be a market for software encoding. I mean, the tuning you can do in
Hmm.
software will be better.
That's right.
But we also, I mean,
That's right.
when we first tested those cards, we were first, the first thing we did was look at the quality. Is it really good? I mean, if the quality is
Hmm.
average or poor, then it's like substandard. And we wanted to have a high quality
Yeah.
encoding. So we were very pleased
Yeah.
with the quality. I mean, if you compare it to GPU encoding, that's bad compared to CPU encoding. But with
Yeah.
the ASICs,
Yeah.
it's in the realms of CPU-based encoding, which is cool.
Just to reinforce that point, because you have seen this data, but perhaps our listeners have not, or not everyone has. So, what's also so important when we're talking about software versus hardware is, like you said, if you have the benefit of encoding a file and then serving it, literally hundreds of millions of times,
Yeah.
and, there's a few platforms in the world that have that benefit. But again, pay close attention to what I just said. There's a few platforms in the world, meaning the whole world. There's like a few,
Yeah.
Netflix, of course, being at the top, and there's the other ones we all know. Um, but what's super interesting is that when you go to live, when you're talking live and you're encoding in software, you can't operate the encoder. So like X264, X265 is a great reference point because pretty much everybody in the industry understands the speed levels and can kind of associate quality at like slow or at medium or at fast or faster or fastest, and the various levels.
Yeah.
So in our evaluation, and whether you use objective or subjective quality metrics, our live performance is on par with X265 medium, and
Cool.
that's live. And there are very few services that could afford to run X265 on CPU
Yeah.
at medium, and just because the compute, you're going to need a lot of cores to do that, and so you're not going to get the density. So true, if you're only running a single channel, well, again, I suppose you could say, okay, fine, I don't care, I'm just going to put a big AMD 64 core machine there, and everything's good, right? But what's super interesting is that the ASIC is able to achieve medium X265 medium speed quality but live, and provide a 20% bit rate reduction on top of that. So not only can it reach the quality but deliver 20% fewer bits at the same time, which is just.
And is that the H.265 encoding as well in the ASICs?
That's
Yeah.
right. I'm talking about HEVC. Yep,
Yeah.
yep.
No.
So, yeah, so it's I also think that's an important reference point. But let's get back to talking about what you built. So what is next? Talk to us about this is a very interesting use case.
Mhm.
I know about the types of projects that you're deploying it into and the regions of the world, and it absolutely makes sense. And I know you're going to do very, very well with this solution. But how are you going to grow it? How are you going to expand? Like what's on the horizon? Are there some other use cases, some other applications that, might either be well known or maybe also novel, that you're targeting?
Well, we never foresaw that we actually would develop an appliance because that's not our business. Our business is SaaS, right? But
Yeah, that's
when this
right.
customer came to us and we said, "Oh, but this is an interesting use case," and we had so much technology on the shelves which we already were using in our cloud. So basically, we just, it's a micro cloud running in an appliance. That's what it is.
Yeah.
So didn't take us that much time to develop this product technically and as a product. So we now have this customer starting to test it. They started testing the software solution. Now they want to test the hardware solution. I don't want to full blown start selling it. I want customer feedback. I want them to operate it for quite some time and then see how they like it and how we should tune it to to have a good fit for them. And then we will make lists of potential customers in markets, and maybe we will do it and sell it ourselves, or we will find a partner, like someone who already has a sales force into certain markets. Some
Hmm.
joint marketing with you guys would be interesting. That those are the things we would be looking at to start selling this.
Hmm.
Um, we're not
Yeah.
interested in selling hardware, right? So we have the software stack. So we will sell it as a turnkey solution, but we will primarily focus on
Yeah.
the software license
Yeah.
for it.
What parts of the world are you primarily focused in, or are you literally selling globally?
JetStream is a European company with a European focus. So our customer base is in
Yeah.
Europe, but our
Hmm.
audiences, of course, are around the world because we have this
Of
CDN
course. Yeah.
we can deliver throughout the world. So, but our primary
Yeah.
customer base is in Europe.
I think it might be interesting to talk about from your perspective. There's an interesting uh, um, challenge that when you talk about the video distributors, the platforms that are, let's say a notch or two, or even a few more notches below, like a Netflix of the world, or the pay TV platforms, some of the large, whether it's satellite or cable or
Yeah.
even IPTV. um, and it's interesting because there's this tension between the content licensing costs, the technology, the business model, and sometimes it's hard to get those kind of proportions correct.
Mm.
And I've seen overinvestment in all of those areas, right? But they're sort of like levers. You need to get them in the right position, or else it's going to be really difficult to make money. You have been in the business for a long time. You have seen the technology expansion and growth, and you've seen the shifts and the changes. And, so do you have any insights about either where, the state of streaming and the technology stack is today, where it's going? Is there anything that you'd like to share?
Technology wise or business case wise or both or
Both is fair game. More and more, it's my encouragement to engineers and people who primarily live on the technical or the product side, to begin to get an understanding of the business,
Mhm.
because I think it makes us better engineers. It allows us to build better products.
Yeah.
And then, always, of course, I think there's a benefit for the business folks to have some understanding of the technology, but
Yeah.
something that I think our audience is primarily going to be engineers. And so
Yeah.
if you have insights on the business side, go for it.
It's interesting if you look at the business rise in the OTT market, like the Netflix and HBOs. Uh, Hardly any of them are making money, right? And that's a challenge, of course. I mean, there's a discussion going on between the telcos and the OTT companies at Mobile World Congress. Companies raised the question like, why should not the OTT providers pay the telcos a little money because they have to keep scaling up their infrastructure. Uh,
Yeah.
I posted something on LinkedIn a few days ago and said, yeah, but if you look at this industry, you have a lot of lost leaders, not just in the OTT space, but also in the vendors. I mean, Name me a vendor that's really profitable right now. Not that many are. And actually, most are loss leading and burning through a lot of money. It's both the OTT vendors and the technology vendors are burning through a lot of money. So basically, they're subsidized by investors who hope that one of those companies will eventually, get better rates or better revenues and or be bought by another company. That's not really healthy. It's not sustainable. I think there are too many vendors in this market space, and I think their expectations have been too high. Some of those companies cannot meet their expectations by the investors, so they're getting into trouble. That's bad, of course. And another interesting observation I made was you have all these telcos, and the telcos are in a crowded, saturated market, but they're making money. And the OTT vendors, the Netflix and HBOs are also, I think they're basically saturated. I mean, there's so many offerings and they have all the audiences, and I don't think they can have more customers as they hope. It's getting saturated, but none of them are really making money. So why why would then the OTT companies start paying the telcos who are actually profitable and those guys are not? So
That's an interesting perspective, and I'm sure Mobile World Congress was not that popular.
no.
I tend to agree with the basic premise, though. So yeah,
If you look at these hyperscale OTT vendors like Netflix and all those guys, they have the budget to put in edge caches within the telcos to negotiate
that's
great
right.
private hearing deals, and that's great for
That's
them.
right.
So I don't think there's a real problem. There is not a challenge
Yeah.
for newcomers in the industry who don't have the deep pockets and
Mm,
don't have the skill. You won't be able to negotiate the same deals with the telcos. You won't be
mm,
able to get your edge
mm,
servers in there. And that means that you will get
that's
two
right.
sides of the industry. Some really high large guys with great performance, great capacity, and low cost, and challengers
Mm,
with all kinds of thresholds to get into that market. And I think
mm,
it touches the discussion on net neutrality. So how far should the telcos be
yeah.
forced to also open up their networks for those guys?
What about any insights on the technology side? And it doesn't necessarily have to be codecs or encoding, but is there anything that you're seeing, any trends, any requests that are coming in from these telcos and these operators, even if they're tier two, tier three, or working in smaller markets that might be interesting?
The markets we work for are medium-sized customers typically who need very
Hmm.
complicated workflows, and that's what we solve with what we call our mix solution, where you can start an easy way and then go under the hood and start tuning and tweaking features, which you cannot do with
Hmm.
regular video platforms. And then
Hmm.
if you go to the expert level, you can plug in your own transcoders, your own players, build your own workflow yourself using our stack of workflow orchestration tools and streaming features.
Hmm.
Um, that's cool. That's we get a lot of positive feedback on this because a lot of people who enter the streaming industry and they're not necessarily have to they not necessarily they are OTT provider. It can also be like an enterprise who needs to do some online video stuff or an
Hmm.
e-learning platform that wants to do something with video or live streaming.
Hmm.
Um, there are two choices in the market. Either you go to a video platform and that's easy. You sign up for not that much money. You can upload your videos and they do everything for you. Get a video player and you can publish it on your website.
Hmm.
Um,
Hmm.
that's but a lot of those companies get stuck there because they cannot optimize their encoding quality. They cannot optimize the player. They cannot optimize the multi-CDN distribution. Don't get access to the data they need. So they get stuck with those platforms. And the step to
That's
go
right.
to building your own stack of technologies is extreme because then you start to have to hire cloud experts, streaming experts who go to
Hmm.
Azure or AWS and start configuring all these modules and sticking everything together. Will take a lot of time, a lot of money to build that, and then you have your own homegrown streaming platform, which does what you need. But what about tomorrow? What about you want to go from
Yeah.
H.264 to AV1 or whatever? You're
Yeah.
stuck again because that's the problem. So That's why we also claim to have this 40% cost reduction. It's not just in traffic or transcoding costs, it's also in operational costs. It's something that
Mm.
people underestimate how much time it takes to build and maintain a streaming platform, and how much expertise you actually need in-house to do that.
Just because you can grab an open source library, which is super powerful, right? And I think it's a wonderful thing. It's great that we have FFmpeg
Yeah,
is developed, as it is, and X264 is, let's face it, it's an amazing encoder. It really is. And X265, it's great encoders. So this is all wonderful, but it's one thing to deploy it at a moment in time. It's another thing to maintain that platform
yeah,
over the life of a service. And I think
yeah,
that is the point that gets missed by
yeah,
by services and companies and platforms who, by all rights, do have smart engineers, and they do have the talent to be able to build it. So it's not that they can't, but it's that maintaining it for the life of the service. That's the part they miss. So it's one thing to build it,
yeah,
have it work today, have it work tomorrow, have it work next month, and even for the rest of this year. It's another thing to have that same service rock solid,
absolutely.
in 2025, when maybe our user base has scaled 10, 20, 30, 40x, 100x, hopefully, over what it is or was today.
So if you look at quality, I mean, most of the content on the web is like HD or full HD. But what about 4K? And what does it mean for your
Yeah,
encoding? What does it mean for
yeah,
your storage?
yeah.
What does it mean for your
You support 8K, that's coming one day. So,
hopefully?
yeah.
There are also two types of worlds coming together. We have broadcasting, traditional broadcasting, and we have internet. And on the internet, we
Hmm.
are used to having very dynamic solutions. I mean, we have to change protocols, you have to change infrastructures,
Hmm.
and what is working today
Hmm.
may not be working tomorrow. While in broadcasting, people are used to build systems for life. You know, you build it, you don't touch it.
Yeah,
Um, and
yeah, yeah.
especially the people who have this more like traditional broadcast attitude of engineering infrastructures, they're having a real hard time to understand the dynamics of the internet because, as I said, tomorrow we can
Yeah.
have. I mean, I'm not. I saw that Safari from Apple, the new latest beta would actually introduce AV1. So then
That's
overnight
right.
this industry can
Yeah,
change, and then how will you change your encoding? And if you have you thought about
that's right.
the effects on your CDN and origins if you start, if you
Hmm.
migrate from
Hmm.
H.264 to AV1? Probably not, and then it will
Hmm.
break, or your
Yeah,
logging will break, or your
yeah,
monitoring. So you have to think about more
yeah,
future-proof things. And by the way, I also saw
yeah.
that Apple pulled AV1 out of the latest beta release. So I'm really curious what's going to happen
Well,
there.
Steph, this has been a really amazing discussion, and I want to thank you for joining the Voices of Video and sharing all of your insights and what you built with us and with the audience. So, thank you.
Thank you, Mark. Thank you.
And why don't you tell everybody where they can go to learn more about JetStream?
Oh, it's simple. It's jet-stream.com.
Well, thank you.